This is the Chapter 7 review. It starts in page 111 in your yellow book. This is covering right triangles. That's what Chapter 7 is focused on. So, let's get started. Number 1, we have the lengths of two legs of a right triangle are 4 and 7. What is the length of the hypotenuse? If we draw out what we have 4, 7 are the legs. We want the hypotenuse. We'll just call it x. This is what we start with at the beginning of the chapter, and that was Pythagorean Theorem. So x squared equals 4 squared plus 7 squared. That gives us 16 and 49. The sum of those two is 65, so I get that x is the square root of 65. The factors of 65 are 13 and 5. I can't break that down anymore, but if I look over at my answers, and it looks like root 65, or the square root of 65, will be my answer. Number 2, the lengths of two legs of a right triangle are 2 root 3 and 5. I need the hypotenuse again, so longest side, hypotenuse is by itself. X squared equals 2 root 3 squared plus 5 squared. X squared equals, now we have to square 2 root 3, so that's going to be 2 squared times 3 plus 25. 4 times 3 is 12. Therefore, I get x squared equals 37, or x equals the square root of 37, and that will be answer A. Okay, we go to number 3. The length of one leg of a right triangle is 4 root 6, and the hypotenuse is 11. We need to find the other leg. So we have to be careful here to make it 11 squared equals 4 root 6 squared plus x squared, are unknown. 11 squared is 121. 4 root squared is going to be 4 squared times 6, which if we go down is 16 times 6. Let me find that out real fast, which is 96. The difference of those two is 25, so x squared equals 25, so x is 5. Number 4, we're looking at a baseball diamond in the shape of a square. 90 feet is each side. We need to know the distance from home plate to second base. Well, if I look just at the right side, or even the left side of this, it's a right triangle with 90, 90, and my unknown hypotenuse. It's that distance across the longest side in the triangle. So I could say x squared equals 90 squared plus 90 squared. That gives me 8100 when I square 90. And if I combine those two, I get 16,200. Of course, I take the square root of that. And before I try to find bigger numbers to break it down, which I could, or smaller numbers to break it down, I could try 2 and then 2 and keep going. Let's notice for a moment this was 2 of those. So it's 2 times 8100. Which 8100, like we saw earlier, was 90 times 90. So it is, in fact, 2 times 90 times 90. We can take that out and make it 90 root 2. You also may notice with these sides being the same, it is a 45, 45, 90, and I can multiply this by root 2 and get 90 root 2 as well. If you saw that, great. Probably saved you a few seconds. Okay, number 5, we have a rocket model is launched. It rises to a point that's 36 feet above ground and 48 feet along the ground from the liftoff site. We need to find the path in the air. It's a right triangle. We are finding the hypotenuse. So x squared equals 36 squared plus 48 squared. 36 squared is 1,296. 48 squared is 2,304. We combine those, we get 3,600, which if we take the square root of is 60. Now, you have also may have noticed this is a Pythagorean triple. We have 36 and 48, which are, if I divide both of them by 12, gives me 3, 4, and that would be 5 times 12, so we get 60. If you didn't see it, it's fine. We can still use Pythagorean theorem, but the numbers were a little bigger and happened to work out nicely in our favor, so 60 was our hypotenuse. Number 6, which set of numbers can represent the side lengths of an obtuse triangle? This goes back to the converse of the Pythagorean theorem. And in the converse, we said that the longest side squared is greater than the sum of the two shorter sides squared. So I'm looking for the one that passes this test. So we got to try each one. We'll do each one anyways and see which one works. So I start with the first one. That's 11 squared equals 10 squared plus 5 squared. 121 equals 100 plus 25, and I get 125 is bigger than 121. That's not obtuse, it's actually acute. Second one, 3, 5, and square root of 34. Well, square root of 34 is almost 6. It's bigger than square root of 25, which would be 5. So we know that that's the biggest side. So I'm squaring that, equal to 3 squared plus 5 squared. Gives me 34, 9, and 25. Well, 9 and 25 is 34. That's equal, so this turns out to be a right triangle. Next one, 3, 7, 8. 8 squared equals 7 squared plus 3 squared. 8 squared is 64. Then I have 49 and 9. I get 64 and 58. 64 is bigger. Biggest side, so that means that would be obtuse. That's likely going to be our answer. We'll check the last one just in case. We'll do it right here. 2 squared equals 2 squared plus 1 squared. That gives me 4 equals 4 plus 1, or 4 and 5, which is acute. So C would be our answer, because the longest side squared was greater than the sum of the other two squared, or what we found right here. Okay, number 7, which represents the length of a right triangle. This is the converse, where c squared equals a squared plus b squared. C is our longest side, a and b are our two lesser sides. Look at the first one. The square root of 5 is my biggest side, so the square root of 5 squared equals 1 squared plus 2 squared. That becomes 5 equals 1 plus 4, or 5 equals 5. So I know that is a right triangle. That's going to be my correct answer, but let's just go through the others just in case. 5, 11, and 12. It's going to be 12 squared equals 5 squared plus 11 squared. 144 equals 25 plus 121. 144 is not equal to 146, so that's out. Well, square root of 10 is a little bigger than 3, so that's not our biggest side. So 8 is our biggest side here. 8 squared equals 6 squared plus square root of 10 squared. 64 equals 36 plus 10. 64 and 46 are not equal. And then our last one, 9 squared equals 7 squared plus 5 squared. 9 squared is 81. I have 49 and 25, which gives me 74. Not equal, not a right triangle, so A was our best answer, seeing that it was a right triangle because it's equal. Okay, we go to number 8. This is where we're now looking at similar right triangles within it. We have that altitude drawn. BD is the value we're looking for. We could do two ways. We could use our geometric mean altitude theorem, or what I like to do is just break it up into two right triangles. I have two right triangles here that I can actually put together to be the whole thing. I have the top piece, which if I label as A, D, B, and of course I'm looking for BD. AD is 9. I have the bottom piece, which if I spin around is B, C, D, where I have BD is here, and CD is 4. Now I can write a proportion. BD is to 4, as 9 is to BD. Now I may notice here that BD is diagonal to itself. Since it's the altitude, it should be such that when I do cross product, I get BD squared equals 9 times 4. BD squared equals 36, which means BD is 6. Okay, number 9 works the same way. I need to draw my two triangles that work. I'm going to look at the whole hypotenuse being 7. So I can draw the big triangle here, x is this side, 7 is my hypotenuse, and then I'm going to draw this triangle, kind of flip it around, and I have x and 6. It gives me the proportion x over 7 equals 6 over x. That's 6 over 7, 6 over x. That becomes x squared equals 42. X equals the square root of 42. And we're just going to circle that answer, which is A. Number 10. Same idea. I have my two triangles. Since I know 12 is this whole length, this is 5. That makes this 7. My small triangle on the left side has an x for the hypotenuse and 7 for the side. My big triangle has 12 for the hypotenuse and x for the side. That gives me 7 over x equals x over 12, or x squared equals 7 times 12, which comes out to be x squared equals 84, or x equals the square root of 84. But if I look at my answers, that's not one of them. I need to simplify. So if I simplify 84 as a radical, that's 2 times 42, and 42 is 2 times 21. I can pair up those 2's, take them out, and that leaves me with 2 root 21 as my answer, so that would be A. Number 11, we move on to special right triangles, and this is a 45 as well. When I go from the hypotenuse to the leg, I divide by root 2. So I'm going to do 3 root 2 divided by root 2, and that merely becomes 3, and that's my answer. Keep in mind, if I went from leg to hypotenuse in this case, I would have multiplied by root 2. Okay, number 12, I have that AB is 16, BC is 17, and I need to find the height. Well, if I look at this triangle by itself, I can't solve with it, but if I just take half of it, that actually gives me a right triangle where 17 is the hypotenuse, h is that leg, and since these two are the same, they're each 8, so 8 is my other leg. That allows me to say 17 squared equals 8 squared plus h squared. 17 squared is 289 equals 64 plus h squared. If I subtract 64 from 289, I get 225 equals h squared, and h would be 15. Number 13 is a special right triangle, a 30, 60, 90. For this one, when I go from hypotenuse, which is my longest side, to my shortest leg, I divide by 2. So x is going to be 6 divided by 2, or 3. And then when I go from my shortest leg to my longest leg, I multiply by root 3. So y is going to be 3 times the square root of 3, or 3 root 3. Look for my answers, and it looks like C is my best option, seeing that x is 3 and y is 3 root 3. For number 14, we have another special right triangle. There's 30 here. First, I'm going to go from my longest leg to my shortest leg, so I have to divide by the square root of 3. I have to simplify that by multiplying the top and bottom by the square root of 3, which gives me 40 root 3 over 3, which is this side. Now, when I go from my shortest leg to my hypotenuse, I have to double it. So I'm going to take 40 root 3 over 3 and multiply it by 2, or 2 over 1 if you need to put it there. So that becomes 80 root 3 over 3, which is our answer B. Okay, 15 is kind of where we start now in looking at our trig ratios. If I say cosine of A is x over 17, and I notice all my answers are in terms of x, I want to look at that equation they first gave me and get x by itself. Well, if I multiply both sides by 17, I clear the denominator out. So I could do 17 times cosine of A equals x, and that would be answer C. That would be equivalent to it. Number 16, I need to find the value of x to the nearest tenth. I look at the values they gave me. I have SOHCAHTOA to help me out. So I know the adjacent and the hypotenuse. Adjacent and hypotenuse means I'm going to use cosine of 25 equals 3 over x. If I multiply the x over, x times cosine of 25 equals 3. Then divide both sides by cosine of 25, it gives 3 over cosine 25. Now, cosine of 25, let's find our trig table here, if we have one. Maybe not. There it is. Cosine of 25 is 0.9063. So we could do 3 divided by 0.9063, or if you have a calculator, you can just do the cosine button. That also works. So 3 divided by cosine of 25. We get it's about 3.31. We can call it 3.3. So A would be our answer. Number 17 is using cosine, and it requires us to draw the actual picture and then make our statement. So I have triangle DEF. Now as I plan it out, I know it's a right triangle. I want to think which one's going to be the hypotenuse, so I make it look correct. Hypotenuse is opposite the longest side. Or hypotenuse is the longest side, and that's opposite the right angle. So I know that DF is the longest side, so that's going to be the hypotenuse. So the right angle is at E. And then ED, or DE, is 15. EF is 36. Now I have my parts. So now when I want to find cosine of F, which is adjacent over hypotenuse, I can look and see it's 36 over 39, which means that cosine of F is, when I divide both parts by 3, is 12 over 13. So that'd be answer B. Number 18, we have an 80-foot support wire. So that hypotenuse almost here is 80. It meets the ground at a 70-degree angle, and we need to figure out the height of the tower. So we make it a right triangle. We're looking for the height. So we have here an angle. That's opposite and hypotenuse. Opposite and hypotenuse means we're going to use sine of 70 equals h over 80. Multiply over the 80, that's 80 times sine of 70 equals h. They gave us sine of 70 here is 0.94. So I need to multiply 80 by 0.94. Well, we don't want to get too stuck to our calculator, so let's calculate that out ourselves. 4 times 0 is 0. 4 times 8 is 32. Then I have 9 times 0 is 0. 9 times 8 is 72. And I get 72, 32. That doesn't seem right. Oops, forgot the 0 up here. Should move that 2 and 3 over. It's okay, your math teacher can multiply. How about 75.2? That looks a lot better. 75.2 is what we get. We multiply 80 by 0.94. So we look for our answer closest to that, to the nearest foot, and it is D, 75 feet. I know, be amazed. Even your math teacher can make an error once in a while. All right, on to number 19. Okay, another of the types of problems we're looking at are trig ratios. We have a ladder leaning against a tree. It hits the tree at a point 15 feet above the ground, so that is the height of the tree. The ladder is a 62-degree angle. All right, and how far is the ladder from the bottom base of the tree? So we're looking for that distance in our triangle. So this is an opposite and an adjacent. So this means we're going to look at tangent of 62 equals 15 over x. That becomes x times tangent of 62 equals 15. Or x equals 15 over tangent of 62. We're kind of going into this next problem. That's all right. 15 divided by tangent 62. Well, they gave us tangent 62 is 1.88. And if we divide, we get that it's about 7.9787. We're just going to call it, it's about 8.0, which is our answer, D. Okay, number 20, we're looking for cosine. That's what all the answers say. Cosine of P. Cosine of P is going to be the adjacent over the hypotenuse. Adjacent to P is E. Hypotenuse is F, so cosine of P is E over F. So we'll go with answer B. 21, we have an angle of depression from the top of a 20-foot lighthouse to the boat in the ocean is 39 degrees. So 20 feet is the height. This angle of depression is actually this angle up here, which we could copy in to right here as well. So we call that 39 degrees. Goes a little bit into our last, or two problems ago, but we can see what we're doing here. We want to find the distance. It's out there. So we could do it this way, or we could draw it in this way. Either way, we're going to use the same ratio. In either case, we're looking at the opposite and the adjacent. So it's going to be tangent of 39 degrees equals 20 over x. X times tangent of 39 equals 20. X equals 20 over tangent 39. Tangent 39 is 0.81. So 20 divided by 0.81 turns out to be about 24.69. So we'll call about 24.7, and that looks very close to answer C. Okay, last one here. We have the angle of elevation. We have 35 degrees is our angle. The height is 60 feet. We need to find x. So we have opposite over adjacent, so that's going to be tangent of 35 equals 60 over x. Multiply over the x, I get tangent to 35 times x equals 60, which becomes x equals 60 over tangent 35. Tangent 35 we have is 0.7, so 60 divided by 0.7 comes out to be about 85.7, which is answer A. So I hope those helped. If there's any areas you had trouble with, try going back and watching the videos that fits to that section. Got to make sure you're good on sine, cosine, tangent, solving with those. But it's also good when you look at a given problem, make sure you can identify what you're really going to use there. So hope it helps and good luck.